Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give two examples related to finding the variance of a random variable. And here what we have is a random variable x that represents the number of dots that you get when you roll a fair die. So clearly this is the case of a discrete random variable because x here represents the number of dots when you roll a die, and therefore x can take these values. So x can take values such as 1, 2, 3, 4, 5, 6. And we know that in this case, fx, the probability of getting 1, 2, 3, 4, 5, and 6 is going to be 1 over 6 for each outcome because the fair is the die is fair. All right. So that's a little bit of background on random variable x. And the question is asking us to find what is the variance of x. And we know from the previous example, we have already demonstrated that if you want to find variance of x, that can be obtained when you consider expected value of x squared minus ex, you squared it. So minus the mean that is squared. Okay, so that's a difference operation involved here. This one is the value of random variable has to be squared first, and then you do the operation here, find the expected value of that. And for this one, basically it means you have the mean, you have mu, and the value of that has to be squared. Okay, right, and this is going to be our starting point. We're going to find what is ex squared. So we're going to find what is this value right here, and we all know how to find that. So the expected value of x squared is going to be, according to the formula, it's going to be the summation of, we're going to take x squared and we're going to put it right next to fx. Okay, and we know that the value of x here is going to be from 1 until 6. So according to these values, x is from 1 until 6. And we're going to take turns switching the value of x here from 1, 2, 3, 4, 5, and 6. Yeah, and the operation is going to look like this. We have 1 squared times f1. Sorry. So this is what we're going to have. We're going to have 1 times f1 plus 2 squared times f2 plus 3 squared times f3, okay, plus 4 squared times f4 plus 5 squared times f5, and so on. Yeah, and this can be further written down as 1 times, so f1, so when x is 1, f1 is 1 over 6, so here is 1 over 6, plus 4 times, when x is 2, f2 is 1 over 6 as well. Okay, so we're going to follow this process. 9, 1 over 6, also 1 over 6, 16, 1 over 6, plus 25, 1 over 6, plus 36, 1 over 6. And if you punch in the values here into your calculator, you should be able to get that the answer to this one is going to be equal to, maybe I can write down here, 91 over 6. Okay, so that is the value of ex squared. Okay, so the value here is 91 over 6. Okay, now the next part is we're going to find what's the value of ex. We're going to find what is ex. Maybe I'll just use this different color. So here we have ex. Ex is much simple. We're just going to put x right next to fx. And again, we know that x is going to be from 1 to 6. So the process is going to be very similar. So we have x is 1 with 1 over 6. Okay, I'm just skipping this part right here, but you know the idea already. This one is 2 1 over 6 plus 3 1 over 6 plus 4 1 over 6 plus 5 times with 1 over 6 plus 6 with 1 over 6. And again, if you punch in the values here into your calculator, the result is going to be 21 over 6. So this is the first result. This is the second result that we get. And we're going to plug in these two results here into the formula. Okay, so this is the formula to find variance. Okay, so we're going to use the results here. Therefore, variance x is going to be 91 over 6, sorry, minus, this is the result of ex, so 21 over 6, and you have to square it. Okay, and you should be able to get that the answer is about 2.9167, or you can also express it in terms of fraction. It's going to be 35 over 12. Okay, so that's the first example related to finding the variance of x. Next, we're going to move on to the next example with regards to a continuous random variable. And here what we have is this specific example has something to do or is related to example 4.3. So in example 4.3, we have done this part. We have this PDF, this one, our PDF here for a continuous random variable x. And in example 4.3, what we've seen is we have done how to find the expected value of x using this formula right here. Okay, so this is the result that you have already seen in example 4.3, and we're going to use that result in order to find the standard deviation of the random variable x. So in order to find the standard deviation, of course, you need to find what's the variance first. And then by finding the variance, you can later get the square root of the variance. So you will find the standard deviation of that random variable x. Okay, so again, our starting point is to find what is the variance of x by using this formula. So ex squared minus ex, and you're going to square that value of ex. Now, bear in mind that the result of ex has already been obtained right here. So we can just plug in the value right next to this position, and you're just going to square it later. Okay, so what we are left to do is we need to find what is this result right here. What is the expected value of x squared? Okay, without further ado, let's continue that process. Now we know that ex squared, according to the definition, is going to be obtained by an integration process where we're going to have x squared right next to fx dx, and we know that the limit for x is between 0 and 1. And I'm just going to write down what is fx. Fx is 4 over pi 1 plus x squared. Hang on. 4 over pi 1 plus x squared, yeah. Okay, so that is my fx. And we know that 4 over pi here is a constant, so that can be taken outside. So we have 4 over pi outside. And this is what we have. Okay, we are left with this. And here we're going to do some sort of manipulation in order to solve this question right here. So what I'm going to do next is, I think this is an interesting part, is I'm going to introduce something. Okay, I'm going to introduce uh, plus 1 minus 1 at the top part of this fraction here. Okay, so I'm going to introduce that. Now, why did I do that? Okay, the reason is because by doing that, I hope you can see that by introducing positive 1 minus 1, I'm actually not changing anything. I'm just introducing something, but that term doesn't change the original expression. Okay, so it's like I'm not introducing anything at all. Okay, because plus 1 minus 1 is actually equals to 0. This is what we call doing some sort of manipulation, and you will see why I did that later on, because then I'll be able to express. Okay, let me just show you what happens next. Because then by introducing plus 1 negative 1, although that is actually doesn't change the original expression, but this process of manipulation here is important, because then I will be able to express, I'm going to rearrange this part here, and I'm going to be able to express 1 plus x squared minus 1 over 1 plus x squared. Okay, this is at the bottom part, and also I can do this if you want, dx, yeah. And by doing that, what I can do is I can simplify that to be written as 1 plus x squared over 1 plus x squared. We can separate that, yeah, this term, and then we can have this minus 1 over 1 plus x squared dx. Okay, so I have managed to simplify that expression before, and then we can see that this part here can be cancelled out, so the result here is going to be equal to 1. Okay, so this result here is going to be equal to 1, and the next process will be I'm going to separate the process of this integration that we have over here. So what we're going to do is we're going to have 4 over pi, and then right now we're going to have 1 0. The result here is 1, so here we have 1 dx. Okay, and then we have the next one is 1 0, and over there we have 1 over 1 plus x squared dx. Okay, now we all know what's the result here. If you integrate 1, you will get the answer is going to be x, yeah. So 4 over pi, so the result here is x, and the limit is going to be 1 and 0. You will substitute that later on, and this integration right here is considered to be classic, how do I say this, some sort of standard result. You'll be able to get, if you have this sort of integral, the result here is going to be the inverse of tangent x. Okay, so the result here is going to be inverse of tangent x, and the limit is going to be from 1 to 0. Now this part here, where you get from this integral to this result, might not be obvious to some of you. So I think I'm going to come up with another video that explains how we get from this to this. Okay, so if you want to find out how can we do that, you can check out on the next video, where I'm going to specifically talk about this part of integral, of getting from if you have 1 over 1 plus x squared, and how do you get the result is as such. Okay, but for the time being, this is what we're going to do. We're just going to write down the result here. The result is the inverse of tangent x, and our next process is to substitute the value for this one here. Is going to be 1 minus 0. This one, the inverse tangent, if you substitute 1 into this, it's going to be negative 0.7854 minus 0. Okay, so this is the result. And you can simplify that process. You will get 4 over pi, 0.21460, and this is going to be equal to 0.2732, more or less. Okay, maybe another one decimal. Okay, so no, this is not the final answer. This is just, sorry, this is just the value of EX squared. Okay, right, so next one is we are going to find what's the variance. Therefore, variance of X is going to be that value that we got, which is 0.27324, and you're going to minus with EX and you square it. So this is our EX. Our EX is 0.4413, and you have to square that value first. And you will see that variance of it is going to be 0.07849. And therefore, since the question is asking you guys what's the standard deviation of X, the standard deviation of X can be obtained by taking the square root of 0.07849, and the result here is going to be 0.2802. So this is the final answer. And I think that's all for now. Thank you very much for watching, and I'll see you in the next video to talk about how from this integral the result that we get is as such. Okay, all right, that's all. Thank you very much for watching.